Welcome back, Viper Nation, to another episode of This Week with Cheek. Hey, this lesson, I'm Professor Cheek as we watch the world of science collide with the world of math. Today we're going to be exploring and learning about scientific notation. Hey, scientific notation is incredible, and professionals outside of the classroom use scientific notation daily in their jobs to help them understand numbers that can be really, really big and then really, really small. You know, chemists use scientific notation, engineers use scientific notation, people working in information technology, even farmers can use scientific notation as they work to better understand numbers. So hey, let's look at a couple of examples. Here's planet Earth. Yeah, many scientists believe that planet Earth is around 4,600,000,000 years old. Wow, that's really old, and it's hard to understand sometimes. Scientific notation helps us reduce the number of zeros that might be in a number so that we can better grasp that number. Hey, another example would be an AMU, or the mass of one atomic unit. Man, it's really, really small. Look at all those zeros. I mean, my mind cannot comprehend how small that is. I can't envision that. Again, scientific notation helps us reduce the number of zeros so we can grasp and work with numbers that are really big, like planet Earth, or really small, like an atomic mass unit. So if we go back to planet Earth, I could use scientific notation, reduce these zeros, and be able to express this number as 4.6 times 10 to the ninth. Clean, smaller, easier, better to understand, easier to understand. I could rewrite the atomic mass of a unit as 1.66 times 10 to the negative 27. Again, reducing the number of zeros that are visible so that I can see or understand this number. So, let's take a look at scientific notation. It's always going to have two factors. The first factor will always be a number that is greater than or equal to 1 and got to be less than 10. The second factor is always a power of 10. So you'll see a base of 10 with either a positive or negative exponent. The exponent tells you how many places to move the decimal. The sign of the exponent, so whether it's positive or negative, is going to tell you which direction to move the exponent. So if it's a positive exponent, we're going to move the decimal to the right. If it's a negative exponent, we're going to be moving the decimal back to the left. Remember, positive exponents are repeated multiplication. So if we are raising a number to 10 to the 8th, it's getting really, really, really big because we're multiplying it by the base over and over and over again. If it's a negative exponent, well, we're dividing that number by the base a repeated number of times, and so it's going to become really, really small. Let's take a look at several examples. We're going to start by converting numbers that are currently in standard notation, just regular notation, into scientific notation. So we've got to create our two factors. So 348,000. The first thing we need to understand is currently where is the decimal? Is there a decimal? Yes, it's invisible, but it is to the right of that last zero. Now, to create a number that is greater than or equal to 1 and less than 10, we're going to place our decimal somewhere between these digits. You've got to decide where that is. So I'm going to place it between the 3 and the 4. That would create a first factor of 3.48. Let's use a different color. Now, scientific notation tells us that we're going to drop any zeros that are to the right of this last counting number, okay? Or if it was a negative exponent, to the left of the last counting number. Now, was that the only place that I could have placed the decimal? Well, let's take a look at that. If I were to have placed that decimal between the 4 and the 8, well, now I've created a first factor of 34.8. That doesn't work. That would be greater than 10. If I placed it before the 3 or to the left of the 3, now I've created 0.348. That's less than 1. So there will always be only one place that a new decimal can be placed to create a factor greater than or equal to 1 and less than 10. For this number, it's between the 3 and the 4. Now, to determine my power of 10 or my second factor, I'm going to count from this new decimal back to the original decimal. For this number, that's going to have me move to the right 5 times. I move the decimal to the right 5 places. Anytime that I move to the right, that's going to be a positive exponent. So I would write my second factor as times 10 to the 5th. Now, another way to determine whether your exponent is positive or negative is to go back to the number and determine, is it greater than 1, which this one is, so it would be positive, or is it between 0 and 1, which means it would be a negative exponent. Let's take a look at our next example. Another really big number, 8 zeros, okay? 8 zeros, 200 million. So first thing, we've got to create a factor greater than or equal to 1, but less than 10. So right now, our decimal is at the end of the number. It's to the right of that last 0. We're going to place a new decimal. So where can I place that new decimal to create a number or to create our first factor? It's going to be between the 2 and the 0. So my first factor is going to be 2. Now I'm going to drop these zeros to the right of that last counting number. And then I'm going to count from my new decimal back to my original decimal. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 decimal places to the right. So my second factor, my power of 10, is going to be 2 times 10 to the 8, a positive 8. That number is greater than 1. Let's look at a couple of examples of numbers that are really small. So you can see already my current decimal is here. Now I want to, again, place a new decimal to create a first factor greater than or equal to 1 and less than 10. That would be between the 5 and the 2. Then I'm going to count from my new decimal to my original. 1, 2, 3. This time I went left. Now my first factor will be 5.2. I will drop these zeros that are to the left of that last counting number. And my power of 10 will be times 10 to the negative 3. Again, I made my exponent negative because I was moving left from new to original. Or you can determine, is my number greater than 1? If it is, it would be a positive exponent. Or is it between 0 and 1? Then it would be a negative exponent. Our last example, and this one can be a challenge. I don't know why this one often throws students off. But it does. So right now we have a decimal between these two zeros. It's to the left of the last 0, really. We're going to place a new decimal. Now, I see a lot of students, they'll put it to the left of the 3, but that creates 0.3 as our first factor. 0.3 is not greater than 1. It's between 0 and 1. So I cannot place the decimal there. I need to place the decimal after or to the right of the 3. Then I'm going to count, so that becomes my first factor, 3. My second factor, a power of 10, will be 1, 2, 3, 4. So it will be negative 4. 3 times 10 to the negative 4. Now, we also need to be familiar with how to convert numbers that are already written in scientific notation back to standard notation. So let's take a look at that. For this first one, 10 to the 4th, I've got a positive exponent. That tells me to move the decimal to the right 4 places. So I've got 2.3, and I'm going to move this decimal 1, 2, 3, 4 places to the right. I'm going to fill these gaps in with zeros, and then my final number would be 23,000. All right, this is important. This is something you need to know, as my dad used to tell me. He would say know when something was really important. So let's remember, our exponent tells us how many places to move the decimal. It does not always describe the number of zeros. There are certain cases where it does. But for this example, look how many zeros I've got, 3. Yet my exponent was a 4. That is because it describes the number of decimal places and not always the number of zeros. Very important, something you need to know. Let's take a look at our second example, 5.7 times 10 squared. So again, our exponent is positive. That tells us to move the decimal to the right. And I'm going to move it 2 places. 1, 2. And then I want to fill that gap in with a 0. My answer would be 570. Our next example, 3.6 times 10 to the negative 3. I've got a negative exponent. Remember, a negative exponent is going to tell us to move the decimal to the left. And so I've got 3.6, and I'm going to start moving 1, 2, 3. And then fill those gaps in with zeros. Now, my final answer, just the proper way, the mathematical manners, as I like to call them, is to place a 0 in front of that decimal. Okay? And then you have the decimal, and then 0, 0, 3, 6. Our last example, and it's somewhat covered up with my hops there. I'm going to erase that. I'll just erase that whole thing. 7.4 times 10 to the negative 2. So again, I've got a negative exponent. I'm going to be moving that decimal to the left. 1, 2. Fill in the gap with a 0. My final answer, 0.074. Now, I mentioned earlier the exponent tells you how many places to move the decimal. It doesn't necessarily describe how many zeros, but if you had a whole number, so I'm going to have another example down here. If you had a whole number, okay, like the one actually that we worked with earlier. So let's just go back to that one, okay? Let's come back over here. I'm going to erase this. 2 times 10 to the 8th. Well, in this situation, there actually are 8 zeros. But that's because our first factor was a whole number. If your first factor is a whole number, then yes, the decimal can describe the number of zeros because that actually will be the number of decimal places or the number of places that you move the decimal. But if it's not a whole number, then that decimal will not describe how many zeros. Again, for example, this was 3.48 times 10 to the 5th. We only had 3 zeros, okay? So please remember, students, the exponent determines or describes how many places to move the decimal. Hey, scientific notation is incredible. And again, it helps us to graph numbers that are really big and really small. It reduces the number of zeros and allows us to understand the kind of numbers that we're working with. Thanks for joining me for another episode of This Week with Cheek.